Alright, so what I'm going to be showing today is how to DLZ through a door with a transition as opposed to a door with a trigger behind it. So if we quickly open the KOTOR toolset, KOTOR tools toolset, um, we wait for the toolset to load. So what we're going to be doing is, like I said, this door has the transition. If you hot shot behind it, you won't be able to hit a load zone because there isn't one. Like it's just the door's transition mesh. Uh, so as we wait to load, I'm going to click cameras, creatures, encounters, merchants, placeables, sounds, and waypoints, so we don't see all of those. Um, you're hiding all of those by clicking them. Um, so then we'll only be able to see doors and triggers. Um, kind of don't really need to have triggers on if you already know it's a door with the transition walk mesh like that, but it's always good to check, like just see there's no trigger behind it, and then click on the door and see, okay, so it says link to module 304, tag is to 304 nar, so that means it's going to be going to the tar, which is a 304 nar. That's the module number for it. So we have the x coordinate and y coordinate, but that's going to be of the center of the door, and obviously we know DLZs only work on the edge vertices of the door. So we take a look at the edges of the door. We kind of draw lines south. We can find some places that seem like they should be able to work. So we're like, okay, let's in that case, let's go ahead and hit graphical editor. We find some bit more information about it here. What we're looking for right now is the appearance is 73 nar Shadda door 01. So we're going to open our KOTOR tool set, or sorry, our KOTOR tool, which is different than the tool set. Um, Minimize this so it looks, so you see in KOTOR tool, open BIFs, 2DA BIF. It's going to be the 2D arrays. You're going to scroll down to the G's. You're going to find generic doors.2da. You're going to open that up. You're going to see, scroll down to 73, nar Shadda door 01. So you can see this is DOR NAR 01. Pretty self-explanatory based on the label. Model names pretty self-explanatory, but they're not always. You can see nar Shadda door 08 is actually DOR NAR 01S. So you want to make sure you know you just want to make sure you check in this array to make sure that you're not confusing yourself and trying to scroll through here looking for door 8 when it's actually 01S. So we're going to close the 2DAs now that we've found that. We're going to go to models.bif. We're going to start with the Aurora model. We're going to go ahead and find DOR NAR 01. Remember, 01S was door 8. We need 01. We're going to hit extract file. It's going to ask you what file you want to put it in. I'm just going to put it in a new folder just so we have a clean folder to look at. I'm just going to say DOR1 just so it's real clear what it is. We're just going to hit save. Now it's in that folder. Now we're going to hit Aurora model extension. We're going to scroll down to the same DOR NAR 01 MDX. It's going to automatically extract to the same folder here. So we're just going to hit OK. And then we're going to do the same for door walk mesh. Now this one's going to be a little more confusing because doors will have multiple walk meshes. You can see how it's easiest to look at NAR01S because that has a differentiating thing. You can see it says 0, 1, and 2. To my knowledge, that's going to be closed, opening, and open. So you just need to close. So just DOR NAR 010 extract file, save. Beautiful. So now what we're gonna do is we're gonna go ahead and go into it's a nice program, MDL OPS. I open it in admin mode. You don't really have to, but Model Ops 1.0.0. Make sure you're on the new version because it's much better than all of the beta versions. So then you're gonna hit select file. We're going to make sure you're in that new folder you just created, especially if you've done multiple of these at this point. And you can see DOR NAR01.MDL. So you want to, like I said, you want to make sure that in that folder you have the MDL, the MDX, and the DWK, all three of them. Otherwise, this extraction won't work. And I believe if you don't have all three of the DWKs, it's going to output. Huh? That's never happened before. Interesting. Anyway, uh, it's tried to delete a file it created. How dare it? How dare it? Anyway, so you see it outputted this error, but if we go into that folder, oops, if we go into that folder, we could see it actually did create the DOR NAR ASCII model. So if we just open that in Notepad++, you can actually see that you can read it and get a lot of good information from it. So we're going to search trans, match whole word, find next. We'll find the node trimesh trans, parent DOR NAR01. Beautiful. So now here you can see we have the vertices of the door. So this is going to be important. So what you want to do is you want to open a new, you don't want to open a new one, sorry. What you want to do is you want to look at these numbers. So I'm opening in a new one so I can delete them without worrying about messing stuff up. So you could see these numbers, this one, this line is going to be the same as this, where is it? 4472, 4472. It's going to be the same as this line here, except that the y is going to be positive, and that the z is going to be different. Now, for our purposes, the z doesn't really matter, because you can trigger the triggers from any z as long as you have the correct x and y. So we need to look at the x and y's. So you can see there's positive and negative version. So we have 2.7, negative 2.7. And we have on both of those, right? On both of those, we have 00504472 and 00504488. Now, these are float points, so that's why the decimals are so long. The difference in practicality of, what is this, tens, hundreds, thousands, 10,000s, 100,000s, millionths, 10 millionths, and 100 millionths of a coordinate, in the practicality of it all, is not going to matter, because the debugger sometimes only goes as far as the thousandths decimal place, and will rarely go as far as 5 decimal places, but even to the 6th decimal place, these are the same number. So for all intents and purposes, for us, these y's are the same number. So we care about the 2.7, the negative 2.7, the negative 0.0005044, and the positive 0.005044. Okay, so now we have 4 numbers for the vertices. What we're going to do is we're going to go ahead and we're going to open Wolfram Alpha. Not Twitch, sorry. There we go. And we're going to go to matrix multiplication. I already have, already have stuff in here, so I'm just going to get rid of that and start from the beginning. Matrix multiplication. This is what you'll get started with. It'll just have silly numbers. So in the glitch hunting channel and in the link in the description, you'll be able to find what matrices you'll be putting in. I'm just going to copy paste it so you can see it's cosine negative a, negative sine negative a, the door's x value, sine negative a, cosine negative a, the door's y value, 0, 0, 1. And the second matrix we're going to be doing is a lot simpler with just x, y, 1. Now, the variables are all stuff that we have now figured out. So the A is actually, if we go back to the tool set, going to be the bearing of the door. I'm going to do this to 4 decimal places, because that's, let's go 5 decimal places. That's pretty much as accurate as our debugger will really ever go. 4 decimal places is really much more, like, I won't even say common. Honestly, it's probably more common for it to be 3 decimal places, but let's be nice and accurate. Let's go 6 decimal places. And like I said, you can see it's negative angle. It's the negative bearing. So if it's already a negative number, what you're going to be putting in is going to be a positive angle. But if it's in positive bearing, you're going to be putting in a negative angle because the the bearings are, I guess flipped, you could say, like inverted. The negative bearings are mathematically positive angles on the coordinate plane. So we want to make sure we invert that so that sine and cosine works properly. Otherwise, you're going to get different numbers, and you're going to be really confused and not getting the right DLZs. So next, you can see it asks for the door X. We're going to go back to the tool set. We're just going to copy that number. Like I said, I guess we're going 5 decimal places, so we're just going to keep that significant figures up. And then we're going to go, and it's going to ask for the door's Y coordinate. Again, very simple to grab. We're just going to go right here and copy it. Like we said earlier, the Z coordinate doesn't actually really matter. So that's kind of what the whole 0, 0, 1 is at the end. You're recognizing that you are rotating it in 3D space, but that the Z is the axis it's rotating on. Now, X and Y in the matrix, the second matrix, is actually going to be the numbers we grabbed earlier. So obviously we can only start with 1, so let's just start with the positive ones. 2.7. And then we're going to, let's close this notepad, keep opening it on accident. We're going to grab the positive Y value as well. So you can see we have much more significant figures on that. So let's just increase into significant figures here. Since it was just 2.7 in there, it means that it is in fact just 2.70000. Compute. And now we just wait a moment here, and you can see it outputted us a nice 4-digit number that we'll need. So negative 97.9467. Let's go ahead and open our regular notepad so that we can just write these numbers down. You can't really copy properly from this website, so just write it down. Make sure you don't write it down wrong. Negative 97.9467. And now, if you remember, there was also the negative version of that, so we'll make the negative x, and we'll get negative 100.784. And then we could also make the y negative. And you could see that we actually got a slightly different x value still, and that's why that matters. So 793. So even though the y value doesn't necessarily matter, it doesn't matter as much for DLZs, because if you remember, you just have to be south of it on the same x value. But for the rotation, having a different value for it does matter, so you want to make sure you try all 4 combinations of the negatives with these numbers. And it can get very complicated if you find a door with 48 vertices, so you want to make sure you really pay attention to what numbers are actually important to you, and not accidentally calculating a bunch of ones that just have the same number with different z's. So try to save yourself some time that way. Oh goodness. Here we go. Okay, so negative 97.9, negative 97.9553. So you can see there's 2 that are very close to each other on both sides, which makes sense because it was just the same x with a different negative or non-negative y. So now we have these numbers. I would save this file as, I would probably save it as tar tunnel DLZ, which I already have one because I did this in practice, but I'll just put 2 zeros at the end just to, I don't know, just to save it. And then you open KOTOR, and you also open your debugger, or cheat engine, whatever method you have for figuring out your coordinate, and you accidentally close everything. There we go. And now you would just use that coordinates. Oh, whoops, I closed that too. There we go. You would use those coordinates to try to find a place to DLZ. So I think you would probably have to go pretty significantly far. Actually, the 100 one here probably could do in this door frame, for example. But somewhere around here, you'd be able to do a DLZ. Oh, I thought I got it. Those flashing lights make me think I get it. But yeah, if you know how to search for DLZs, it's the same method. You just sort of rub the wall and find it eventually. So yeah, hopefully that helps someone, and yeah, hopefully that makes it so that people are also able to help find DLZs themselves too, because it's pretty useful when you're able to have multiple eyes searching for stuff. So thanks for watching. Hopefully this was helpful. Went a little longer than I meant it to, but hopefully it was pretty comprehensive. Thanks for watching. Take care. Bye-bye.